It didn't look revolutionary, but once it showed up, railroading never worked the same again. There was a moment when railroads stopped caring about power and started caring about uptime. That shift happened the second diesel proved it could outwork steam. Today we're looking at the EMD F-Unit, the locomotive that quietly redefined what winning on the rails meant. Number 8. Built around consistency, not peaks. By the late 1930s, railroads were done with engines that only worked when everything went right. Steam could make huge power, but it needed constant attention, water, fire, pressure, and crews all in sync. What railroads really wanted was repeatability. So what happens when a locomotive is designed to deliver the same output hour after hour, instead of chasing maximum power? That philosophy defined the F-Unit. Its diesel-electric layout wasn't about speed records, it was about controlled power delivery. The engine drove a generator, the generator fed traction motors, and power reached the rails smoothly, without spikes. There were no sudden surges, no pressure management juggling. Power came on evenly, stayed predictable, and dropped off the same way every time. Dispatchers could plan around it, and crews didn't have to fight it. Once railroads understood how an F-Unit behaved, it behaved that way every single run. That consistency mattered more than excitement. It meant fewer delays, fewer surprises, and fewer decisions under pressure. But consistency doesn't come from power delivery alone. It also depends on how the machine is built, protected, and expected to live in the real world. Number 7. The car body was a functional decision. The F-Unit's full car body is remembered for its looks, but it wasn't about style. It was built to protect internal systems and control airflow, sealing everything inside from weather, dust, and debris. But what do you gain and lose when you fully enclose a locomotive? What railroads gained was reliability. Wiring, electrical gear, and cooling systems stayed cleaner and more stable. Components lasted longer, and failures became less frequent. What they lost was flexibility, and the access for switching work was limited. Visibility wasn't ideal in yards. But the F-Unit wasn't meant to be a yard engine. It was built for mainline work, long runs, steady speeds, and minimal interruptions. In that environment, the enclosed car body wasn't a drawback. It was an advantage. Design choices like the car body solved some problems outright. But the real operational breakthrough came from how these locomotives worked together, not just how they worked individually. Number 6. Multiple unit control changed everything. One of the most important features of the F-Unit wasn't mechanical at all. It was multiple unit control, the ability to run several locomotives from a single cab. Why did that matter more than raw horsepower? Because it changed how railroads scaled power. Instead of designing one massive engine, railroads could link 2, 3, or 4 units together and control them as one. Crews stayed the same, but the power increased and scheduling became simpler. If a train needed more pull, you added another unit, not another crew. If one unit needed maintenance, the others could keep working. Power could be matched precisely to terrain, train length, and seasonal demand. Railroads no longer had to overbuild locomotives for rare worst-case scenarios. They could plan operations around predictable, interchangeable units, reducing downtime, simplifying training, and improving fleet efficiency. That modularity gave railroads a level of flexibility that steam never allowed. Once railroads could scale power easily, the next question became simpler. How long could the heart of the machine keep doing that work without complaint? Number 5. The 567 engine was designed to be boring. At the heart of every F-Unit was EMD's 567 diesel engine. It wasn't revolutionary because it made extreme power. It was revolutionary because it didn't try to. Why would an engine's greatest strength be restraint? The 567 was built to operate well within its limits. Thick components, conservative tuning, and plenty of margin. Instead of squeezing every bit of output from the design, EMD focused on longevity and serviceability. Crews could predict how it behaved. Shops could plan maintenance instead of reacting to failures. Parts wore slowly and evenly, and when something did need attention, access was straightforward and standardized across the fleet. It didn't feel dramatic, but it felt dependable. Starts were consistent. power delivery was smooth. And over thousands of miles day after day, that quiet reliability mattered far more than peak numbers ever could. A reliable engine is only part of the equation. What truly determines how that power reaches the ground is what happens after it leaves the crankshaft. Quick pause. If you're enjoying this kind of breakdown, where we focus on how machines actually worked in the real world, consider subscribing. These stories don't get told often, and there's a lot more like this coming. Number 4. Traction. Motors did the hard work. Unlike steam, where power delivery depended heavily on mechanical linkage and wheel adhesion, the F-Unit relied on electric traction motors at each axle. What changed when power delivery moved from rods to motors? The difference was control. Instead of dumping power all at once and hoping the wheels held, the F-Unit fed power in smoothly. Wheel slip stopped being a constant fight, and heavy trains started moving without any problem. Even on bad rail or in poor weather, the locomotive stayed composed. It didn't shove against the track, it worked with it. That made everything easier. Parts lasted longer. Fuel was used more efficiently, and for crews, the job stopped being a physical battle and became something predictable and manageable. It wasn't flashy, but once railroads felt that kind of consistency, there was no going back. All of that engineering only mattered if it translated into something crews could actually live with, hour after hour, mile after mile. Number 3. Crews learned to trust it. A locomotive's reputation lives and dies in the cab. No specification matters if crews don't trust what's under them. So how did the F-Unit feel about running day after day? It was predictable. Throttle response stayed the same every time. Power came in smoothly instead of surging, and small adjustments stayed small. Engineers knew exactly how the locomotive would react before they even made the change. Crews stopped bracing for surprises, also stopped fighting the machine, and started working alongside it. The engine no longer felt temperamental or unpredictable, it felt steady, almost routine. At the end of long runs, operators weren't worn down by constant corrections or sudden behavior changes. That reduced fatigue, lowered stress, and helped crews stay focused. Over time, that consistency quietly reduced mistakes and made day-to-day operations safer. But here's the twist. Everything that made the F-Unit so reliable on the main line slowly made it less useful as railroads changed how they operated. Number 2. Too specialized for a changing railroad. As dieselization spread, railroads wanted locomotives that could do everything: roadwork, switching, yard service, and branch lines. And what happens when a machine is very good at one job, but average at many others? This is where the shift became obvious. The F-Unit was built for long, steady miles at speed. It excelled on main lines where trains ran for hours without stopping. But it wasn't made for constant stops, tight yard moves, or situations where visibility in every direction mattered. Its full carbody-limited sight lines and switching work was never its strength. Road switchers began to take over because they were more flexible, not because they were better built. They could handle yards, locals, and mainline work in one package, which fit how railroads were starting to operate. The F-Unit didn't fail. The railroad itself changed, and the job changed with it. And that's what makes the F-Unit worth talking about today. Not where it fell short, but what it proved when everything aligned. Number 1. Why the F-Unit still matters. The EMD F-Unit represents a moment when engineering priorities aligned perfectly with real-world needs. It wasn't flashy or experimental. It was disciplined engineering, focused on uptime, consistency, and trust. Without locomotives like the F-Unit, dieselization wouldn't have happened as quickly or as completely. Railroads needed proof that diesel wasn't just viable. It was better for the system as a whole. Freight kept moving, passenger schedules held, maintenance became predictable, and the industry shifted permanently. The EMD F-Unit didn't change railroading by being exciting. It changed railroading by being reliable when it mattered most. So the real question is this: do you value machines that impress, or machines that quietly keep everything working? Drop your thoughts below. And if this breakdown clicked with you, check out the video on the channel where we dive into how diesel reliability ended the steam era step by step. It pairs perfectly with this story. And if you want more deep dives like this, hit subscribe. More are coming.